Welcome back. So we've introduced the basics of what we're going to be looking for in order to get ultimately to our confidence intervals. So if we know sigma, life's pretty good. You could probably do this part as it is without me saying more about it, right? We get the same critical values that we did in the previous series. If you know sigma, well, there's sigma. You've got a sample, so that obviously gives you n because you've got a sample size for your sample. And then you've got E. You then run E and your sample mean, and that gives you your confidence interval. That's all you would need if you know sigma. But if you don't know sigma, we've got to start talking about these t values. We got to start talking about t values. So what is t-score? Well, I'll give you the full formula. Not that, again, we're going to need it that much in this class. But what happens is we are not able to use z-scores if we don't have sigma. And that is because, well, the z-score equation is your value or your sample mean minus the population mean divided by sigma, or sigma over n for a sample, right? That was from the central limit theorem. That was 6.4, I believe it was in the text. But anyway, you'll notice that we've got mean and standard deviation popping up in this formula. We don't know mean because that's what we're trying to find. And if we don't know sigma either, that's two unknowns. One equation, two unknowns, not going to fly. That's just a fundamental thing about problem solving. We can't use this if we don't know mu and sigma. I cannot know one, I cannot know the other, but I can't not know both. That sounds awkward. I have to know at least one, is what I'm trying to say here. But for this, if I don't know mean, that's what I'm trying to find, and I don't know sigma, then I have to use the t-table. Now, this is a standalone table in the same way that you can Google z-tables, so you can Google t-tables, and it will tell you something very similar. This is an adjusted z-score. It's adjusted, accounting for the fact that I've got small sample sizes. Here's the equation here. It's basically, you'll note it's basically the adjusted z-score that we had for the central limit theorem, but it's used for smaller samples where you don't know sigma. And it's going to be a little bit different. That said, as the sample size gets larger and larger, you'll notice that these values get increasingly closer and closer to the z-scores. The critical values for the z-table. So it does approach the critical numbers of z alpha over 2s as we get closer and closer to having an infinite or a sufficiently large population or sample size, But we don't always have that. In fact, we don't have time to sample everyone. And if we did, we wouldn't be doing statistics. We'd be doing just number crunching parameter business. So let's talk about this table. I've got here at the very bottom the parts I care about the most personally. I really like this table because it's sorted by, well, it's got the stuffy statistics at the top, but at the very bottom is the part I like. Confidence level. So you can start from the bottom and go up. Let's say I want a 95% confidence level. In fact, if you don't have an idea what to shoot for, 95 is usually the one you default to, right? I usually go higher if there's a risk of loss of money or loss of life. Lower if you don't really care about the accuracy or being wrong. But 95 is just the good middle value. So we're going to start at 95%, and we're going to go up on this column until we get an appropriate number of samples, or actually DF, degrees of freedom. So what this table will tell you is you'll go by column for your confidence level, and your row is going to be your degrees of freedom. And I'm going to give you the most insultingly simple formula in the history of formulas. It is the number of points in your sample minus 1. So if you have 11 points in your sample, 11 data points in your sample, then you would have 10 degrees of freedom. If you have 101 sample points, then you would have 100 degrees of freedom. Of course, if you have like 120, then it would be technically 119 degrees of freedom, but you'd still use the 100 here, just because that's the closest you're going to get. And that's it. So that's how we use the table to look up our critical values. That's what we'll do there. Then we'll use our new equation, and then finally we'll produce the confidence intervals. And that's really the big changes between what you've been doing. We'll work some examples in the next video. I'll see you then.